surface area. Perfect. So we know h is equal to 50 times L. So I need to find my surface area. So the total cost, which is my surface area, is equal to the cost of the base plus the cost of my sides. Which means that the cost is going to be, so how much does my base cost per centimeter squared? How much does my base cost per centimeter squared? Okay, so we have 2 times 5L plus the cost of my base, which is times 1. And what are the costs? What are my sides? What are the dimensions of my sides? And how many of each do I have? So I have 2 times 5h plus 2 times L times h. So I got 10L plus 10h plus 2LH. So because I have an expression in terms of h, what can I do with my expression in step 2? What can I do with my h? What can I sub it in for? What can I sub in for h? $50 over L. Thank you, Adarayo. So I get 10 times L plus 10 times 50 over L plus 2L times 50 over L. So these L's cancel out. So I get 10L plus 500 to the times L to the negative 1 plus 100. So this is an expression for my cost. So now I have to find my domain. So my length has to be greater than 0, and my h has to be greater than 0. But I know my h is 50 over L is greater than 0. Cross multiply, so the L just cancels out. So I get 50 is greater than 0, which means that this is always true, which means my domain is going to be L is less than infinity and greater than 0. So that would be my domain. And then last but not least, we can use our expression from what we have. So the minimum cost in terms of L is equal to 10L plus 500 L to the negative 1 plus 100. So if I take the derivative of C of L, what is my derivative, guys? What would my derivative be? It'd be 10 minus 500 L squared. Thank you, Priyanshu. Which is just the same thing as saying 10 minus 500 over L squared. Now we have to set my C prime of L to 0 because it's a max or a min that we're finding. We're going to move my negative 500 over L squared over. So I get 500 over L squared is equal to 10. Multiply both sides by L squared, so I get 500 is equal to 10 L squared. Divide both sides by 10. I get 50 is equal to L squared. I'm going to take the root of both sides, so I get plus or minus the root of 50 is equal to L. Can I simplify my radical root 50? Can I simplify that? How can I simplify root 50? So I get 5 root 2, thank you, Anna. So I get plus or minus 5 root 2 is equal to L. Can I take both solutions, or is one of them inadmissible? So my positive one is going to be the only one that works. So L is equal to positive 5 root 2, and L is equal to negative 5 root 2. This one doesn't work because it's less than 0 and does not fall in my domain. So now for number 5, I have to check. So I'm going to check my cost at 0. It's going to give me undefined because when I sub in 5 root 2 for 500 L to the negative 1, I get a denominator of 0, which gives me an undefined number. C at infinity is just equal to infinity. And then the cost when my length is 5 root 2 gives me a total cost of 241.42, which means the minimum cost is $241.42. Here's we're going to go to our second last example, and then the last example you guys are going to do. So example 2, we have a man lives on an island 1 kilometer from the mainland. His favorite restaurant is 3 kilometers along the shore from the point on the shore closest to the island. The man can paddle his canoe at 3 kilometers per hour and can jog at 5 kilometers per hour. Determine where he should land so as to reach the restaurant in the shortest possible time. So first of all, I need to start with a diagram. So we have my island over here. So I draw my, tropical trees, an umbrella, stuff like that. So that's my island. So the guy lives 1 kilometer from the mainland. So let's name this point P. So his favorite restaurant is 3 kilometers along the shore from the point closest to the island. So from here to here, so this is the restaurant. This in total is 3 kilometers. So we know that the man can paddle his canoe at 3 kilometers per hour and can jog at 5 kilometers per hour. So we want to determine where he should land so as to reach the restaurant in the shortest possible time. Okay? So obviously he has to canoe. So when he canoes, he can't just go right there because the hypotenuse is obviously the biggest thing. So when he canoes, he's going to canoe along here, and he's going to land somewhere over here. So you can label this as x over here and 3 minus x, and then label my hypotenuse as my y value. So now I have to figure out my information. So I know I can figure out an expression for my hypotenuse by using my Pythagorean theorem. So I have x squared plus 1 squared is equal to y squared, which means that y is equal to plus or minus the square root of x squared plus 1. We can't take the negative because we can't have a negative measurement. So we can only take y is equal to x squared plus 1. So we're going to let y represent the distance canoeing. And 3 minus x is going to represent the distance jogging. So remember, it's a combination of him paddling to a certain point along the shore and where he can run as well and reach his restaurant in the shortest period of time. So if you guys have taken physics, we know that distance is equal to speed multiplied by time. So I have my little triangle over here. So d is equal to s times t, or we're solving for time, so time is equal to distance divided by speed. So my total time is going to be my distance canoeing divided by the speed of my canoeing plus my distance of jogging over my speed of jogging. So my distance for my canoeing is represented by y divided by my speed, which is 3 kilometers per hour, plus my distance jogging, which is 3 minus x, divided by my speed of jogging, which is 5 kilometers an hour. So I know I have my y in terms of x, because we figured out that the y can be represented by the square root of x plus 1. So I get x squared plus 1 over 3 plus 3 minus x over 5. So just based off of my expression, I can tell right away that my domain is going to be x is less than or equal to 3 and less than, greater than or equal to 0. Because if I isolate for x in x squared plus 1, I cannot take the root of a negative number. So I have to assume that my x has to be between 3 and 0. That and the length of the shore is 3 kilometers, so it cannot exceed 3 kilometers. So now I have to come up with something to find my derivative. So I take time in terms of x is equal to 1 over 3 bracket x squared plus 1 to the 1/2 plus 3 over 5 minus 1 over 5x. So I'm just making it simple so that we can simplify our derivative easier. So now I have to find my derivative of my expression. So I need to use the power of a product or the power of a function rule for my first one. So who can tell me what my derivative would be for 1 over 3 times x squared plus 1 to the 1/2? So my derivative of that becomes 1 over 3x times x squared plus 1 to the negative 1 over 2 minus 1 over 5. So we set t prime of x is equal to 0. So we get x over 3 times the square root of x squared plus 1 minus 1 over 5. I'm going to move my negative 1 over 5 over, is equal to x over 3 times the square root of x squared plus 1. And now all I have to do is cross multiply. So I get 3 times the square root of x squared plus 1 is equal to 5x. So now what I'm going to do is I'm going to square both sides first, so I get rid of my roots, which means I get 9 times x squared plus 1 is equal to 25x squared. And I get 9x squared plus 9 is equal to 25x squared. I'm going to isolate for x. So I get 9 is equal to 25x squared minus 9x squared, which gives me 9 is equal to 16x squared. And then I can divide both sides by 16. So I get the square root of 9 over 16 is equal to x. So plus or minus the square root of 9 over 16 is equal to x. And I get either x is equal to plus or minus 3 over 4. Can I take both answers, or is one of them going to be inadmissible, and why? So can I take both roots, or is one of them inadmissible? Remember, we're talking about time over here. Okay, so cannot use the negative because time is not, can't be negative. So we're going to reject negative 3 over 4. All right. So now I'm going to evaluate t at 0. which gives me 0.93 hours, t at 3, which gives me 1.05 hours, and t at 3/4, which gives me 0.86 hours, and this is my minimum time. So my statement would be, therefore, you should land 0.75 kilometers from the closest point to the island.